Hello, everybody. Thanks for sticking by. I know that you want to basically run away from the conference at this time. Me too, I want beers, so I promise I will be quick. Today we'll be talking about building animations and transitions for web applications, but it's also a story about delivering stuff for production, and I'm going to share with you a couple of lessons that I learned from my mistakes. I hope that you can make a good use of them. So, super quick introduction about me. I'm Jeremias Menichelli. I'm pronouncing my name like that because I'm from Argentina. Currently, I'm living in Barcelona in Spain, working at Typeform as a front-end engineer in design systems. And those are a bunch of useful URLs. Most of the material that I'm going to present today is going to be there, so feel free to check out after. So a summary of what we're going to talk about today. First, we're going to see how routing and views work in React. I don't know if you are familiar with React. Can you raise your hand if you work with React at least once? OK, most of people. If not, I promise that it's not going to be all the talk about React, and to share some knowledge around general web applications. So after routes and views, we're going to talk about React transition group and animations. Then we're going to see a recipe about how we can combine them to achieve custom transitions per route. So each route of our application is going to have a different animation. Then we're going to talk about kicking off transitions on first load. It's actually the reason that this talk exists. And then we're going to wrap up and go over some conclusions and then beer. So let's start. First of all, we're going to see routing in React web applications. We have a couple of options around, but the most popular one, I think, is React Router. And it comes with a bunch of useful components. The ones that we're going to see today are browser router, the switch component, and the route component. So super simple example in code of how these three work together. You're going to see that we have the application code. We have actually navigation. And we are wrapping everything in a browser router component. So this component basically just handles all the logic between history in the browser and the location URL changes. And then inside we have a switch component, and the switch component decides which route should render. You know that we have three routes here in the code. We have the home, the about, and the author page, and that's basically it. So assuming that we have content on each route, our application should look something similar to this. You see that in the application in the GIF, when the user clicks the link, the content changes below. No animation yet. We're going to get there, so don't worry. So transitions. I'm going to use to showcase this, the React Transition Group package. It's kind of like the community official one. And it comes with three components. The first one is the transition group component, then the CSS transition, and the low-level transition component. And again, super quick, how they work. So let's say that we have a pop-up, and we want to apply the fade-in, fade-out animation to that pop-up every time that we showed it and we hide it. So we have a pop-up, and we wrap everything in a transition group component, and then we use something to toggle that component. In this case, I'm using like a Boolean that is open. So imagine that we have a prop or a state that is changing over the course of the life cycle of our application, and this hides or shows the component. And we're wrapping our pop-up component in a CSS transition component. So basically, the CSS transition is going to toggle some class names on the node. So we can use those class names to animate in and animate out the component. So in this case, I'm using class names fade. And what's going to happen is that every time that the component enters, I'm going to get a fade enter and a fade enter active when the transition is done. So I can just use two classes for enter, two classes for exit. And in 4 lines of CSS, I had a fade in, fade out animation. So you can see that I'm using the fade enter. And I say, hey, you know what? I want to go from opacity 0 to opacity 1. And when I'm exiting, I want to go from opacity 1 to opacity 0. Straightforward. And this is super useful also for sharing transition between multiple components. So let's say that I'm rendering a list, and every time that the list item is getting out of the DOM, I want to animate it out. So I just map everything, and I wrap each component in a CSS transition component. And with the same code as before, I'm animating all the list items. So that's a CSS transition component. But I want to talk about the transition component, which is way more low level. And I think that the CSS transition actually uses it under the hood. This is the same code as before. You'll see that the only thing that I changed is the transition component. Here, The thing is that if we don't do anything, like nothing happens. We don't have like a CSS class name that toggles, anything. But every time that the component gets unmounted and gets remounted again, we have a couple of hooks. We can pass functions. They're going to get called every time that this happens. So in this case, I'm showcasing the onEnter. That's going to get fired every time that the component, like in this case, the pop-up gets into the DOM. And every time that React decides that the element should go out, then the onExit callback is going to get called. So not big a deal. Of course, inside these functions, we can run GS animations, do calculations, whatever we want. So the thing is that on the project that this talk is based, I was using the old APIs for both React Router and React Transition Group, which were really good for custom transitions per each route of our application. They moved to new APIs, and to be honest, I like them more. I like way more how React Router code looks now, and I really like this new API for React Transition Group. But for custom transitions, that specific case got hit. And it's not that easy. It was like a little complex. And I had to relearn the API for the talk. And I wanted to show you like updated code and not old code. So yeah, it was kind of a headache, but it's possible. It can be done. And I'm going to show you how. So let's go back to our previous code, actually to our previous GIF. And what we want to achieve is basically this. You see that now we have animation on our transitions. And you see that when I hit the about and the outer page, we have this slide up animation. But when I hit home, I get a completely different animation. Like the home page gets each line of the title, which is not the one. We have different content in about and in outer, and we have another content in home. So I want different animations in each of them. So going back to the code, as I was saying, we have the browser router, we have the switch, and we have the 3 routes. So what we're going to do is to concentrate only on the switch part, so avoid the noise. And the problem with this is that I can wrap my routes in transition group and transition components. Because if I do that, then the React Router package is going to stop working. Like it's just not going to work. So I'm going to do a super small change to this. 3, 2, 1, done. So go back again. So basically what I've done is that I wrap everything in a route component. Just that. The app is still working, it's doing the same, nothing has changed. The good thing is that every time that the location changes, that function is going to run. So I'm going to be able to do some triggering. So wait, this is a lot of code, so let's go over it. We still have in the middle the switch and the 3 routes. And I'm wrapping everything in a transition group component and then transition component. But just one, not 3, not mapping. So what's happening here? So you see that in transition component, I'm passing a key, a unique key that is generated by browser router logic. So for those that haven't worked with keys in React, every time that you switch a key to a component, it doesn't matter if it actually is a different component on the same component, it's going to force the unmount a remount, even if nothing has changed. And I want that every time that the route and the location changes. So that line, passing the key, is like the magic. It's just that. By passing the key, I'm saying, hey, if the location has changed, then unmount the previous transition and mount a new one with a new route. And then I just use the onEnter hook to animate the entering of the view. And what React Transition Group gives me on that callback is the node and a Boolean if the component is appearing for the first time in the application or is an inner navigation. We're not going to care that much about that today. So I'm grabbing this callback, and I'm calling my own enter function. And you see that I'm passing the path name as the first argument, and then I'm passing the node and the Boolean. And the node because I need to animate the DOM, and the path name because I'm going to use that path name to decide whether I want to run the home animation or the about and outer animation. So digging in and getting into the enter function, what I'm doing is basically, in this case, I'm using Greensock, but you can use like any GS library that handles animations or timelines. When this animation function runs, basically says, hey, what is the path name? Is home? OK, give me the timeline for home, and I'm going to play it. And if not, then give me the default timeline, and I'm going to play it either way. So pretty straightforward, nothing magical. So that's all the heavy coding on the talk, at least. So until now, I know there's a little bit React, but now we're going to move to lessons, and they're going to be general for all web applications. And this is what I really want to talk today to you. And it's about kicking off transitions when your applications first load, because that was a trickery part around performance and about animating the view transitions. And I'm bringing this topic because actually I was working on a project in my previous company, and a designer comes to me and says, hey, I was checking the application in our staging server, because this wasn't released. And the homepage animation is not looking good. And when I check it, yeah, it was super laggy. It was horrible. The animation was nice, but the performance was horrible. So, okay, so I had to fix that. So my first try was to move the animation to the next frame. How we do this? We just use request animation frame. So when we're building our timeline, we build it post, so it doesn't run immediately. And before hitting play, we just wrap everything in a request animation frame function. What this is going to do is going to queue the callback to the next frame of the browser paint. So that's pretty much it. Super simple, one line of code, and it didn't work, of course, because it's web development. So I went back to the code and said, OK, let's try the next thing. The next thing was to actually move 2 frames after the render. And I know it sounds silly, it kind of was, but the reasoning about this is that my next frame, when I'm mounting the application, is the frame that actually React is doing all the heavy job. And I don't want to run the animation when React is super busy doing the mounting. So I actually want to move 2 frames. So how you do this? Like, again, super simple. We're skipping 1 frame, now we're skipping 2. So we wrap the request animation frame in another request animation frame. It's really smart move. It was really cool. Didn't work. Here's the nope. The third try was actually to use browser hints. I don't know if you heard about it. It's not a lot of fuss around browser hints, but it's actually a will change property. Raise your hand if you know will change. OK, you're not. You could. The rest, you're not missing anything. Because basically, will change came here as a promise to let us, web developers, hint the browser when something is going to get animated. So you basically set the will change property to transform to any element, and the browser will know that you're trying to animate that, and it will run some optimizations on top of that element so your animation runs smoothly. The thing is, will change to me, at least in my case, in my experience, has been like a broken promise. That's what I told you, that you're not missing out anything. Technically, by spec, you set the will change property, and you need to wait till the browser runs the optimizations. But we're talking about a CSS property, which is fine. I love CSS. But when do I know when the browser is ready running the optimizations? Actually, the browser, by spec, can bail out on running the optimizations and not do anything because it decided not to do it. How do I know that? So yeah, no way to react to that. And of course, I did the change, check on staging, and it didn't work. So I moved to my 4th try, which was change basically the methods from GreenSock that I was using. In my experience, at least, the from method in GreenSock performed better than the rest. So I changed all my CSS, then I changed all my animations, and it didn't work. It was definitely a desperate move, so it makes sense that it didn't work. So by this time, I was probably spent the whole day trying to fix a performance issue, and I wasn't successful, so I was feeling really tired and really frustrated. So first advice that I can give to you is that when you're burnt out and you can't do anything about it, you can't think clearly, just close a laptop, don't feel guilty, go home, rest. A fresh mind is always better than a busy mind. So I did that. I went home, opened a glass of wine, and relaxed. It was kind of like this. Will Ferrell is more funny than me, but good thing is that I got some sleep and came back to the office after this day. And I started my day not with a try, actually, but with a decision in mind, which was, actually, why don't we open Stage Insight and run a profile and audit in DevTools? So I did that. Maybe I will find something. So, surprise, I found something. I know it was like a statement, but at least it was a hint. And you will see that we have our animation time tag there by DevTools in Chrome. And you will see that we have 2 lines crossing in the middle of the animation. So these 2 lines are indicating the load event and the DOM content loaded event from the browser. So basically what this means is that we're kicking off our animation, but the browser is still updating the DOM, parsing a resource, doing some heavy tasks. So the browser is not ready. So I said to myself, I definitely don't want to run an animation if the browser is not ready with the essential things on the first load. So I'm going to start with that. So how we move the animation of our timeline to after the load event, right? So if you know add event listeners in browsers, that's pretty straightforward. We have our timeline, and we wrap our request animation frame timeline play in an add event listener. And that's it. No, that's not it. It's really dangerous to do that. Why? Because if for some reason the load event fired before we declare the listener, then the animation is never going to run, and our content is going to be like opacity 0, hidden, or unanimated, and we don't want that for sure. The other problem, this is not reusable, so what if you have a bunch of animations kicking off from different components or async bundles in our animation application? So you can wrap everything and hope that all the event listeners are declared before the event fires. So this is not good too. And the other thing is that if you're actually covering a little legacy browsers, you will find a lot of difference between when the load event fires if you have async and defer scripts. So how we solve this? With promises, because promises are here for that, for async things that happen on the browser and our application. So the thing is that the event listeners are not promise-based. So how we turn these event handlers into promise-based? So with just 1 line, I placed this in the head of our document in the application. So by doing that, I'm pretty sure that it's not going to be declared after the event fires, because I'm loading the script of my bundle after that. So this is a safe move. And it's just 3 lines of code, you'll see. Basically, I'm declaring a new promise, and the promise is going to get resolved when the event listener runs. And because I'm exposing this globally, I can use this like anywhere in my application. If I have an animation on my footer, on a banner, don't put banners on your applications, but well, if you have to. So yeah, this works because they not just do, the load promise, then run the animation. The big question is, does this solve the issue that I was showing to you? Yes. You will see that now we have the 2 lines that were shown before that were in the middle of the animation. Now we see that they're way before the animation. And actually, I checked the staging server after deploying this. Problem solved. Performance wasn't an issue anymore. So the final question is if we all should do this on our applications. If you're running animation, do this, put a global, and put then, and forget about it. So quick answer, no. Because this is a solution, this work is in production right now in some site. The thing is that do something if it's really going to solve a problem that you're having, but the final take around this is please profile your applications. So if you're having some issues with performance, let's open DevTools, let's run an audit. It's just about, I know that it's like messy, I don't understand all the stuff that I'm seeing when I'm opening a performance audit on DevTools, but we need to interact more with the DevTools and learn our way through it. So to end, a couple of recommendations around running animations on web applications and all these lessons that I learned. So the first one is that when an animation is happening, nothing else should be happening. So if you have, if you're parsing a resource, if you're fetching data, and if you're updating the DOM, if you're doing something, try to move your animation out of that time. Like animation and performance gets hit like super easily by anything happening on your application. If you can't do it, just like, actually don't do any animation. No animation is better than a crappy animation. Your users will super love you if you just show the content and they can use your application and move forward. That's what they want. And if you can do animations and they look good, awesome. If not, let's avoid them. Testing on slow devices, we all have like great MacBook Pros and iPhones, whatever. But our users have a lot of diverse devices. And also try to test if your server is not that fast, what happens to your resources and to your applications. And I'm going to say this again, please, let's profile our applications. Let's see if we find something, and if we have a performance issue, let's solve it by running some metrics. So a couple of resources, and I'm ended, and we're all going to have some beers. The first one is that the repository for the application that I show you on the GIFs is real. You can fork it, you can clone it, you can run it locally and test. You can actually see all the code. I didn't want to like bash you with even more code than I did. But you can check it out, and if you have any doubts, you can reach out to me. I'm going to be tomorrow also here. This promise-based thing, these 3 lines of promise and event handlers that I show you is actually an article that I wrote like 2 years ago, so you can check that out. The React Router documentation around transitions is really good. When I needed to relearn all these new APIs, I used this, and this was really helpful. And then we have the React Transition Group documentation. It's not that good, but it's there. Check it out. So that's it, WebCamp. Thanks a lot.